Sideboard, Fun Sock Friday, the 26th of February, the day after the funniest day of the month. You guys will be able to factor by using the distributive property. Okay, let's write our name on these. Me llamo Senior Castle.
My name's Maddie. I want to go to bed.
Okay. All right. So let's look at a definition first. Factors. So factors are numbers and or variables that divide evenly into a term. Another way we think of factors is numbers or variables that multiply to get to something. So if I said, what are the factors of 6? I'm asking what multiplies to get to 6. Okay, so if I'm asking for the factor of 6, we could say 2 and 3 or 1 and 6. So we'd say those are the factors of 6. Okay? And now, do all of those divide evenly into 6? Yes. Yeah. And so that's another way to think of factors, okay? So what are the factors of 72? It's a bigger number.
8 and 9.
Okay, 8 and 9, very good.
2.
1 and 72.
Okay, 1 and 72. 2 goes into it. It's an even number. 2 goes into it.
7. 2 times 7 times.
36. Thanks. Okay. You can do your calculator. Does okay? Does 3 go into 72?
Yeah.
We can try it. Take 72 divided by 3.
24.
Yeah, 24.
Uh-huh. Does 4 go into it?
Yep. 18.
Okay.
30.
Does 5 go into it?
No.
How do you know?
It's a 2
Oh.
and a 5.
Okay.
That's a good reason.
Okay, it doesn't end in a 0 or a 5. 6 goes into it. How many times?
12.
12. And 7 doesn't go into it. And then we'd be done. Let's look at this. This is how we know we'd be done. We covered 1, 2, 3, 4, 5 didn't. 6, 7 didn't. 8 does. Then do we need to try 9?
No.
No, we already get it coming back. That's how we know we covered all of them.
9.
Okay? Now, we have a prime number. Does anyone know what a prime number is? Okay, you gave me an example. 5 is a prime number. Why is 5 a prime number?
It's odd. It's like one number.
It
Like
goes
it's
5,
not
10,
negative.
15.
It's
Yeah,
not.
5, 10, 15, 20.
Not quite. 7's a prime number, but 8 is not. 9 is not, but 11 is. 12's not, 13 is.
Is it like 3, 6? No.
So a prime number is a number greater than 1 whose only factors are 1 and itself. So it doesn't have any factors other than 1 and itself. So like 5, what multiplies to get to 5? 1 and 5, and that's it. So it's prime. Nothing other than those. Nothing than 1 and itself. And 1 and the number are always going to multiply to get a number. Because 1 times anything is just the other thing. But you can't multiply 2, 3, okay? 7 is prime. Nothing times anything else other than 1 and 7 will get it. 9's not prime. The y isn't 9 prime. 3 times 3. 10's not prime. 5 times 2. 11, nothing times anything is going to be 11, except for 1 and 11. Okay? Does that make sense or no? What a prime number is?
Yeah.
Okay? So then if we have a prime number, we have what we call a composite number. So it's a number that's not prime. So if it does have other factors like 4, 2 times 2, 6, 2 times 3, 8, 2 times 4, okay? Those are called composite because they're not prime. Now 0 is not either. It's not prime nor composite. It's considered just to be neither, in case you're wondering. Okay. Have you guys ever heard of prime numbers before?
Yeah.
Okay.
And I'll be honest with you, I've never heard of prime numbers until I started working here.
Really? Yeah.
I don't know why they didn't teach that.
Is this a section of math that we're never going to use ever in our life?
I don't know.
I can't tell you.
That's my question, too.
Because you
So here's the thing. No, it's not why. No, I mean I'm being completely honest with you. I'm always honest with you guys about this kind of stuff, right?
Yeah.
Okay. Okay. Well, I mean I am being honest, but I mean, I guess that's your choice whether to believe it's true or not. But anyway, so whether or not you'll use this or not, okay, I don't know entirely. Because certain professions will, certain professions won't. Do I know exactly where each of you are going to go?
No.
Okay. I mean, I know we had a conversation the other day about, hey, where you want to go, that kind of stuff. But are any of those set in stone?
No.
No. So even you don't know exactly where you're going to go. So do you know exactly all the education and training you need for that specific thing?
No.
No, because you don't know what it is yet. So what this is designed to do, what all of your courses here are designed to do, are to give you guys as many possible tools and resources, so that way, whatever you go into, we prepare you the best we can for that. So whether or not you go into this, you're ready to. Or you're set up for success to go further down that path. And so even if student A might not use this, and student B would, well, they could have easily switched. Does that make sense?
Yeah.
So that's part of it. So even if you might not use this, okay, well, your neighbor might. Okay? Or your neighbor might switch at the last second to not using it. Or you might switch at the last second and end up using it. Okay? And then the cool thing, honestly, about math, okay, is regardless of whether or not you use the specific skill exactly, do you have to think in math? Do you have to think about what you're going to do next? Do you have to think about how to get there? Okay, you're solving problems, aren't you?
Yeah.
Okay, so that's creating what we call critical thinking skills. Does anyone know what critical thinking means? Okay, critical thinking means you're thinking critically. Okay, well, duh. Okay, so thinking critically and critical thinking means that you're not just kind of like randomly like thinking about some random details about something. You're picking something apart. You're looking into it in depth. Okay, you're taking a better look at something. You're taking a look at a scenario and you're saying, what can be done with that? How can I figure this out? Here's where I'm at. How can I get there? Those kind of questions. Those are critical thinking questions. And so math, these problem-solving skills we're teaching you inside of these other skills can help you think critically. They can help you solve problems. Yes, in math, but also just teach you how to think and solve other problems in life. Oh, should I do this or this? Should I go on a trip this weekend or should I stay at home?
Trip.
Okay, well, what are the costs? How much time would you be able to spend there? Is it worth it to drive 6 hours round trip to spend 2 hours there?
No.
Those kind of questions, those are critical thinking questions. Sometimes it may be, sometimes it might not be. Okay? So those kind of things are skills that you're actually learning while you're doing this kind of stuff. Does that make sense?
Yes.
Yeah.
So the actual math, you may or may not. Can't guarantee it, honestly, straight up. Even if you don't use the math skills, the critical thinking skills are just honestly insanely valuable. Anyway, little sidebar on that. All right. Hey, here's some tips and tricks for whether or not a number goes into something else. Honestly, guys, you're going to want to put like a big star next to this section or highlight it or something, okay? I don't know about over the section, but
You see a big star.
Yes. So that way you guys are able to come back to this and know exactly where it is. This is very helpful for what we're going to do, okay? And it's actually just really nice later in math too. I still go back to these all the time. Rules for divisors, aka rules to see whether or not a number is divided by this number. So, hey, is a number going to be divided by 2?
Yes.
Well, is it even?
Yes.
What does even mean?
2, 4, 6, 8.
It ends in 2, 4, 6, 8, or 0. Okay? So if it ends in one of those 5 numbers, 2 goes into it. If it doesn't, 2 doesn't go into it. 3. The sum of digits is divisible by 3. We just had the number 72 a bit ago. What is 7 plus 2? 9. The sum of digits, 9, adding up the digits, is 9 divisible by 3?
Yes.
Yes. So is 72 divisible by
Yes.
3?
Yes.
So if I give you guys a number, you don't have to write these down, obviously.
Okay.
513. Is that divisible by 3?
Yes.
Yes.
Yes. 5 plus 1 is 6. 6 plus 3 is 9. 3 goes into it. So you know right away if it does. Now we'd have to divide to see how many times it does go into it. But we know instantly whether or not it does. That's kind of cool. 728.
Yes.
No.
What's the sum of the digits? 17. Does 3 go into 17?
No.
No. So does 3 go into 728? No. So what we did is we turned this into a much easier division problem. 17 divided by 3 versus 728 divided by 3. And now we know 3 doesn't go into it.
I'm so confused.
Sorry, maybe you'll be more appreciative. Okay?
I
Or-
get 13.
What was that? I just came up with random numbers.
Oh, I'm so confused.
I just picked random numbers that I knew wouldn't work because I was adding them in my head as I was thinking about which ones to do. If 4 goes into something, if the last 2 digits are divisible by 4, so if you have a really long number and the last 2 digits are divisible by 4, 5,280. The last 2 digits, 80. Is 80 divisible by 4?
Yes.
Yeah, so this whole thing's divisible by 4. You instantly know. Okay? Now, for numbers like 67, that's not very useful. So here's the way I would do something like that. Or even a number like 66. I would say, try dividing by 2. And does anyone know what 66 divided by 2 would be? 33. And then I say, okay, can I divide that 33 by 2? No. So if you can divide by 2 twice, 4 goes into it. If you can't, 4 doesn't go into it. And here's why. 4 is double 2. So if you can divide by 2 twice, it's the same thing as dividing by 4. That makes sense or no? Because what's 100 divided by 4? 25. Haha. What's 100 divided by 2? 50. What's 50 divided by 2? 25. We got the same thing. Divide by 2 twice or divide by 4. Same thing. So can you divide by 2 twice? Yes. Okay, you can divide by 4. No, can't divide by 4. 5. Reagan said this one earlier. Does it end in a 0 or a 5? If yes, okay, 5 goes into it. If not, 5 doesn't go into it. Yeah.
Wait, so we can't just divide 66?
Sorry, what was that?
No.
Oh, so 66, 3 goes into it. Is that what you're asking?
No, like, instead of doing, like, 66 divided by 2 times,
Mhm.
we can't just do 66 divided by 4?
So you could try it, but it wouldn't end up working.
Okay.
So this is I'm just trying to teach you ways to kind of test and see does it or does it not before you go through all the division. So you could say 66 divided by 4 and it wouldn't work. You'd end up getting 16 and a half. We can say divide by 2 and then we can instantly see it wouldn't go again, so we can stop there. So it might just be an easier test for some people.
Okay.
Yeah, that make more sense?
Yeah.
Okay. Does the number divide by 6? Okay. Was it divisible by both 2 and 3? Okay, well, 72. Is 72 divisible by 2? Yeah, it's even. Is 72 divisible by 3?
Yes.
Yeah, its sum is 9. So if it's divisible by both 2 and 3, you can divide it by 6. And we said a moment ago, 6 times 12 was 72. And that works because 2 times 3 is 6. Just like 2 times 2 was 4. So that worked. Okay. The 8 one, honestly not that useful. It's there. You probably won't use it. 9. The sum of digits is divisible by 9. Is that pretty similar to anything we've seen?
Yeah.
The 3 one, right? Instead of divisible by 3, though, for 3, you say, is it divisible by 9? Okay, well, what's 7 plus 2?
9.
9. So is 9 divisible by 9?
Yeah.
72 is divisible by 9. 5 plus 1 plus 3.
Yeah.
What's that? 6 plus 3, so 9. So it goes into that. Now what if I give the one something like this? 669. What's 6 plus 6? 12. What's 12 plus 9? 21. Does 9 go into 21?
No.
No. So it is not divisible by 9. Does 3 go into 21?
Yeah. Oh, yeah.
So it's divisible by 3, but not by 9. Does that make sense or no?
Yeah.
Okay. 10 doesn't end in a 0. Okay. And that's our test for those. Okay. So and there's other ones for later ones, but these are honestly the most handy ones.
Okay.
Okay. So like I said, you're gonna want to put a big old star or highlight this section. Okay. So that way you can come back to this section pretty easily because it's stupid helpful.
I put a big stuff.
Okay. Yep. Yeah.
What
Yeah.
else,
Good
Rick?
luck. I mean, it'd be ideal. But okay. We're gonna talk about this idea of a greatest common factor. Have you guys heard of that before?
Yes.
Okay. What does greatest mean?
Biggest.
Biggest. Okay. What does common mean?
Relatable.
Okay. It's relatable. It's shared. Okay. They have it in common. They share that. Okay. Factor. We talked about numbers that go into another number. So the greatest common factor, or sometimes just called GCF, greatest G, common C, factor F, okay, of 2 or more integers, numbers, is the greatest number that's a factor of all the integers. So if I'm talking about like the number, I don't know, 72, we used that one earlier, so I'll keep using it. And 36. Well, we listed the factors of 72 just a moment ago. We said the factors of 72 were 1 and 72, 2 and 36, 3 and 24, haha, 4 and 18, 6 and 12, and 8 and 9. What are the factors of 36? Let's walk through these. Okay, well, we know 1 and 36, that's kind of a freebie every time. 2 goes into it. So now we just need to figure out, okay, how many times?
13.
Not 13, a little more. 13 would be 2 times, would be 26 for that. So 2 goes into it. How many times do we know? What's half of 36? Not quite. 25 is half of 50, so a little lower. 18. Hey, what's 36 kind of close to? What even number, or kind of like nicer number? Yeah, 40. What's half of 40? 20. So we just need to go a little bit lower. Okay. Does 3 go into 36? What's 3 plus 6? 9. Is 9 divisible by 3? So 3 goes into it. How many times?
13.
A little less. 12. Okay, well, does 4 go into it? 9 times. Okay, does 5 go into it? No. Does 6 go into it?
6 times.
Yeah, because 2 and 3 both do. Now, we noticed we went up in order. 1, 2, 3, 4, 5 didn't. 6 does. And then as we start going around the other end, did we catch all of our numbers? Yeah, so there's none we missed. Now, they have lots of common factors, right? Different common factors are 1, 2, 3, 4, 6. What else? 9, 12, 18, and 36. So which one of those is the greatest? 36. So we'd say here, the GCF of these two is 36. This is a skill that will be used on your homework, but it won't be just like this. Okay? So the GCF would be 36. Okay? Questions on that? So the GCF here would be 36. Does that make sense?
Yeah.
So you found the biggest number that went into both. So sometimes it's most helpful just to write out all the factors of each. And like how I write them in pairs, this times this, helps you to kind of just get all of them. Okay, it's organized. Before I go to the next slide, I'm going to kind of alter a bit. I'm going to kind of change where I was going a little bit. So if I said, what were the GCFs of x squared and x to the third? Okay, well, this is kind of a different way to think about it. How do you get x squared by multiplying? X times what would get x squared? X. And that's it. Or 1 times x squared, right? Okay, 1 times itself. And that would be it. So we can kind of go about it the same way. Let me rewrite that. 1 times itself. Let me write it this way. Or x times x. And just like kind of we went up, 1x, x squared. Okay, we covered everything. Okay, we see a repeat there. Well, x to the third, we can have 1 times x to the third. Or we could have what times x to the second? Just an x. Would x to the first times x to the second be x to the third? So, these have some different common factors too. What are some different common factors we see here? I heard some. X squared. What else is common?
1.
X and 1. So which one of those is the greatest?
3. Oh, 2.
X squared. So the GCF of these two is x squared. Because they both have at least 2 x's there. So we can kind of change beats here a bit and say, okay, well, if I give the numbers 8x and 10x squared, what could I say is the GCF of these two things? What's the greatest common factor of 8 and 10? What's the greatest number that goes into both 8 and 10? 2 goes into both. Okay, if we figure out the factors of 8, we have 1 times 8, and 2 times 4. Are there any others? What are the factors of 10? 1 times 10 and 2 times 5. What's the greatest common factor there? 2. Now, how many x's do they also have in common? This one has 1x. How many x's does this have? 2. So it's essentially like x times x. So they both have at least 1x in common. So our greatest common factor is actually 2x. So they both have a 2 and an x. I'm thinking about something. I want us to try a factor tree. Okay, so in this, we have a little bit of space here, kind of on the right side of our notes here, right? We have a couple problems like right here and here, don't we? Okay, then we have this little bit of space over here where I'm kind of drawing right now, don't we?
Yeah.
Okay, I want you to write this in that little space right now. I want you to write so write this like if 1 was here, 2 is here, scribble. Kind of right at the end of 2, I want you to start writing this first one, okay? Does that make sense? But you can write it up above, right below where it says the greatest common factor thing. And I want us to write, let's go with
That one looks so straight.
16. Pretty proud of it. And 84. Okay? And what we're going to do is we're going to find the greatest common factor of these two numbers. And I'm going to teach us a different way to go about it. I'm going to see if this works better for us. Okay? We're going to do what's called a factor tree.
Dude, I remember these from like 4th grade.
You do? Good. Okay? So, a factor tree. We say, what two numbers multiply to get 16? Just pick any two.
2 and
8.
8.
Cool. So 2 and 8. Now, can any numbers multiply to get 2 other than 2 and 1? No, so 2 is prime. So that part of the tree that branch ends. Is 8 prime?
No.
No. What multiplies to get to 8?
4.
4 and
2.
2. So, can 4 keep going?
Yes.
Into what and what?
2 and 2.
2 and 2. Can 2 keep going though? No. So we look at every branch of the tree, and we say the factors of this end up being really 2, 2, 2, and 2.
2.
Okay? Does that make sense? Okay. Let's look at, let's do the same thing with 84. What 2 numbers can multiply to get to 84?
42.
Okay, I heard 42. And what?
2.
2. Okay, so 2 kind of ends there, doesn't it?
Yeah.
What numbers can multiply to get to 42?
21.
Okay, 21 and
2.
2. Okay, 2 ends again because it's prime. Is 21 prime?
Yeah.
No.
No, what goes into it?
3 and 7.
3 and 7. Can you split 3 and 7? No, they're both prime. Okay. So if we look at the ends of all the branches, on 16 it turned into 4 different 2s. On 84 it turned into a 3, a 7, and 2 2s. You guys see that?
Yeah.
2.
Okay, 2 2, haha.
So 16.
So, we say, out of all of this, what all do they have in common for these branches?
2.
2? How many 2s do they have in common, though? This one has a 2 and this one has a 2. So they have another 2 in common, right? Do they have anything else in common for the ends of their branches? No.
No.
So we multiply those circle numbers together out of one set. So what's 2 times 2? 4. So the GCF is 4. Does that seem similar to you guys or no?
Yeah.
Okay. We're going to practice that then. Okay, we're going to practice by factor tree. Yep. Yeah. Sorry, what was that? Oh, that was just where, so like on your note packet, you have like underneath this, you have like a 1 and a 2, and you have like problems. And so I was just saying, hey, like at the end of 2, draw kind of like a little line there to separate it out. Okay. We're going to have like kind of an abbreviated homework today, yeah.
Alright.
Yep.
So not like the full homework sheet?
Probably not, no. It's actually going to be a different homework sheet. I'm going to kind of change my mind on how I'm doing this.
I like what you were doing up above. But whenever we have to find the first square,
Yeah.
because where I was trying to try the first one, it is first square, so the next one is first square, yes, you can stop and pull that out.
Mm-hmm.
So I like that type what you were doing there. This to me is much easier, I'm like changing it out.
The factor tree? The factor tree is more convenient? Yeah.
For me.
Yeah. We're scrapping the factor tree for now. I'm kind of in my own head right now. I'll be honest. I thought about trying to do this differently than how I normally do. Yes. Yep. I apologize. Okay. We're going to go back to what we were doing a moment ago and say, hey, what goes into this number, what goes into this number? Okay.
So you will, Lainey.
I think it'll make more
Set
sense.
yourself, open your mind up, because what he was trying to do right there is gonna cause you more work, and you're gonna have bigger math to try to figure out how many times and how many 2s you got and all that. So just
Mhm.
open up your mind and let this come in.
Yeah. Let's go through the distributive properties on the board here, okay? So the same one you guys just did, we said that was 6a plus 12, and then Ms. Hazel showed you guys can go back and factor that back out, right? That was one you literally just did.
Yeah.
Okay. So if we were to distribute the other one, well, it's 2x times 4x. 8x squared. We just did that, right? 2x times 5.
Yeah.
10x. Now, could we factor back out of there?
Yeah.
Sure, same idea. What do they have in common if we were to go the other way? They have a 2x in common. Very good. They have a 2, but they also have an x. So then if you take a 2x out or divide 8x squared by 2x, what do you get?
8 or
4x. Are we seeing that 4x again? Is that familiar?
Plus 5x?
Plus, not 5x, but if you take the 2x away from 10x... Okay. Let me do this one off the side again. So we said they have a 2x in common, right? So what we're going to do, just like Mrs. Haswell showed over here, you're going to divide both of them by whatever you take out. We're going to divide 8x squared by 2x. Well, we did that last chapter. You guys remember that? Problems like this?
Yep.
Okay, what's 8 divided by 2? 4. And then with the x's, what do you do with those when they're dividing? Subtract. So what's 2 minus 1? X to the first. So that's how we get this 4x. Does that part make sense?
Yeah.
Okay. And then with the 10x, same idea. Divide that by 2x. 5. And is there any x?
Oh.
No, because 1 minus 1 is 0. So that's how we get the 4x plus 5. And is that right back where we started? Yeah, same idea. So all factoring is this just the reverse of distributing. So we distributed to go one way, then we factored, pulled things out to go the other way.
And then I flipped the page and then I...
Okay? So when you factor down here, we factored out the 3, and we said, okay, well 15x divided by 3 is 5x. 9 divided by 3 was what, guys?
3.
3. And we say, okay, well, it's factored because nothing goes into 5x and 3 anymore inside the parentheses. And what was your GCF, the thing that went into both 20y and negative 35? 5. And you were left with a 4y minus what? 7. And nothing went into those, did they?
Nope.
Alrighty. So let's go on to the next page here.
No, we're not going to.
Okay, we're going to do the next 2.
Jace.
That sound good?
Yeah.
Okay. Okay, Gucci. When I say Gucci, you say gang. Gucci.
Gang.
Gucci.
Gang.
Awesome, that was a joke. Okay, I appreciate that. Okay. 12x squared plus 3x. What do we think our greatest common factor might be between 12x squared and 3x? 3x! 3x. Do they both have an x in common? Yeah. So we're going to pull a 3x outside the parentheses. Now let's say, what's going to go inside, okay? Now later, as we practice more and more of these, maybe you'll get better at doing them in your head. But if not, we can write them off to the side every time. So you can practice 12x squared divided by 3x. 4, I heard it? X, because 2 minus 1. So we're going to be having a 4x here. Then 3x divided by 3x is what? 1. So plus 1. Now, if Mr. Castle, how do I check my work if I want to be an awesome math student? Well, thank you for asking, okay? How you check your work is if you were to distribute the 3x back in, do you get what you started with?
No.
Try it. Try it real quick. I'm serious. Try it real quick. On your paper, try it.
What do I try?
What?
Try distributing the 3x back in and see if you get what you started with.
12x.
My head. Yep. My head said yes.
Do you get the same thing as you started with? Then you did it right. Boom. Instantly can check if you did it right or wrong.
Wow, awesome.
On 4, there's more going on.
Oh.
What's our greatest common factor on 4 here?
Just split it up, guys. and
Okay,
divide by one
so-
at a time.
Yep, go through one at a time. Let's do the numbers first. 9 and 15. What's the greatest common factor? 3. X squared and x. Go to the next thing. What's the greatest common factor of x squared and x? How many x's do they share? 1. Okay, y and y squared. How many y's do they share? 1. So that's going to be our GCF. We say, hey, what is each GCF? I like that, Ms. Aswell. Split them up. All right, once again, we can divide them off to the side. 9x squared y divided by 3xy. Once again, go through part by part. 9 divided by 3 is 3. X squared divided by x is just x, 2 minus 1. And then you don't have anything for y, right? So you just write 3x. The minus sign is going to carry back down into here. Does everyone know why I put a minus sign in the parenthesis? Minus sign originally, right? Okay. So let's do the 15xy squared divided by 3xy. Well, what's 15 divided by 3? 5. X divided by x? Nothing. 0 x's, so just 1. Okay. What's y squared or y? That should be a y squared. Yep, divided by y. Oh, it is. I was looking at the wrong thing. It is a y. So 5y. And how could you check your work if you wanted to? Distribute it back in, and we'd get the same exact thing. And we also say, inside the parentheses between 3x and negative 5y, is there anything else they have in common? No. Because if there is, can we go farther? Yeah, you could. Questions on that? Alrighty. Okay, we're going to stop there today.
Yeah.
We're going to do part of the homework. I want you guys to do numbers 1 through 3 and 7 through 11 for now.
really not.
That's literally